So for what we did for ACL, so ACL had this initiative this year of providing translation, subtitles, and dubbing. Let's start with the translation. So translation of all the ACL papers into 60 languages. So this is for the translation part for the papers. Second one is they also wanted to have all the talks on the ACL to be subtitled and dubbed into, again, 60 languages, but because of the time, we ended up with just 10 languages. The UN languages plus another 3 languages after that. Also for the papers, they wanted to extract all the like the top keywords and scientific concepts from the papers from ACL and find the translation in 60 languages. So for example, if we are saying machine translation in English, how should I translate this into French or Arabic? It shouldn't be like a direct translation. Maybe I come up with a different concept that represent the same meaning, but in that target language. That was the main target at the beginning. And another target is to have all of that being done fully automatic without human involved. And in the next year, they are going to open like shared tasks or competitions between the researchers so they can compete between each other to get better results than what the current machine is doing, like the current state of the art that we have this year. So we are going to use what we implemented as a baseline for what they are going to do next year or whatever. So this is in general what they asked for. What we did. Explain was like the main focus, like the main point of integrating all of this stuff together. So there were other people from Yale and the Alan Turing Institute. They were working on extracting the keywords from the paper. So this is what they have done outside. Also, Aptic implemented a specific ASR for ACL vocabulary. And Baidu optimized the model for the translation. And all of that is onboarded on aiXplain, and we use the designer to integrate all of that. So on the designer, we built a pipeline that can take an input paper and translate it into the 60 languages we are talking about, and just put the output in the JSON format they are asking for. Just as simple as this, just a pipeline that takes an input node and with 60 outputs, all of them are translated in one of the language. And all of these are being run in the same time, like in parallel processing. This is for the translation. For the subtitling and videos, we used Aptic ASR to transcribe the audio file provided in the talks. And then the output from the ASR sent to 10 machine translation nodes to be transcribed and to be translated in the target languages, and then connected to text-to-speech. We used Google, the premium model, to give a good voice. And that's it. One thing we done within a script node is if the segment that is synthesized is longer than the original segment, let's say we have a video and the pipeline cut this video into smaller segments. Each segment has like 5-7 seconds as a duration. Maybe after you transcribe, translate, and then synthesize, you end up with a voice in the target language that is maybe 10 seconds. So how should you fit 10 seconds on the original 7 seconds duration? What we did, which is not the best thing, we just speed up this segment. So like if you watch the Minions, the sounds look like the Minions after that, like. So it's like this funny voice. But again, this is what we did in the ACL, and this is what they imported on their platform there. What we are doing now, we wanted to enhance this dubbing and subtitling pipeline. So what we are doing now is we are implementing the state-of-the-art subtitling and dubbing systems. So now, to avoid this problem of like longer duration and shorter duration from the original one, now we try to control the number of words in the translation to make sure the output translation is like somehow aligned with the input segment. So let's assume we have 30 characters in the input sentence. I will try to have like a 30 characters in the output segment as well. So when the text-to-speech reads that, it will be like somehow within the same duration of the input segment. Even if we speed this up, it will not affect the quality of the speech after that. So that's what we are calling now dubbing node and subtitling node. Those are not yet available in the platform, but hopefully in July we have these nodes onboarded and anyone can use them. So this is in
And
general what we did for ACL.
might this also be something that could be part of a competition where it's not just the translations or the finding
We
the
can
keywords, but
compete
it could
now.
also maybe be like the
No,
script node part? Or
actually, we can compete now, right?
yeah,
As a system, like because in the previous one we didn't generate something out of Explain. What we did in the previous one is just connecting Aptic to Google to AWS through the pipeline using our designer, right? But now we're building this subtitling and dubbing node. This is now Explain thing. It's different than what we implemented for ACL.
and it's kind of a
Because,
unique offering, I guess, in the marketplace too,
yeah,
or
yeah,
yeah,
because there is no subtitling or dubbing node function I am aware of. Like
yeah.
it's something good. Like to have it within your pipeline and you can build on top of that other application. That's a nice thing to have.